Hello, everyone. We are live once more. Once more, getting Streamlabs set up like with 1 second to go. Well,
Oh yeah.
negative 4 minutes to go, I guess. Uh, yeah, yesterday the sharing the live share with the REPL did not work properly, so we're trying a different approach this time.
Yeah. Um my camera now that I think about it, my camera will very likely just be gone if I share screen. But, take it.
Yeah, I had to like reset up all of my windows and transforms and things like that. But uh, hopefully we're all good. Okay. So
You
let's.
read it yesterday, so I think I should read the one today.
Yeah, go ahead.
All right. Everybody, we got to let the shame out. Take a big boy drink. Hmm. Protein shake, not like whiskey or anything. All right, day 2. Rock paper scissors. The elves begin to set up camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between two players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. Then, a winner for that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play: A for rock, B for paper, C for scissors. The second column, suddenly, the elf is called away to help with someone's tent. Darn it. The second column, you reason, must be what you should play in response: X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected: 1 for rock, 2 for paper, 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, 6 if you won. Now, this is like mini World Cup. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide: A, Y, A, Y, B, X, Z, Z. This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, A, and you should choose paper, Y. Right. This ends in a win for you with a score of 8. 2 because you chose paper, 6 because you won. In the second round, your opponent will choose paper B, and you should choose rock X. This ends in a loss for you with a score of 1, 0. Yeah. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3 equals 6. In this example, if you were to follow the strategy guide, you get a total score of 50.
Cool. So
What would your total score be if everything goes exactly according to your strategy?
so basically we are for each line uh parsing the what the symbols mean, uh doing some either like lookup table for victory or just like a switch statement or something, and then doing a sum at the end. And for sure part two is going to change what y, x, and z
Yeah.
mean,
Oh
because
yeah, classic.
otherwise it would just be ABC for both of them. So I bet. What would this be in part two? Is part two going to be like y means that you lost, x means that you uh, drew, z means that you won, and you have to work out what the opponent played or something? That's my bet.
Yeah. I'm thinking there might be like a very silly way to like actually code this up.
I think I'm gonna
Um,
do. I'm gonna do a lookup table because then I can show people multi-dimensional spans which are coming in C++ 23.
oh, Oh, you're finally yeah, you're getting multi-dimensional arrays.
Finally.
That's
Well, I mean, we've
finally.
had multi-dimensional arrays, but the thing about multi-dimensional spans is that you can have like a single dimensional array, so everything is contiguous in memory, and then instead of having like multiple dimensions in the data itself, you just have a multi-dimensional view over this one-dimensional array, which is really good for performance reasons in some use cases.
By view, you mean like you can look at contiguous subarrays and
Right.
not copy them implicitly?
Exactly. Yeah.
Okay.
So
Okay.
like you say you have a one dimensional array which logically represents a two dimensional array. Like in this case, we've got
Hmm.
3 by 3, right? So you'd have a
Yeah, one, two, three, and then four, five, six, seven, eight, nine.
yeah. So that would be the one dimensional array would just be like an array of 9 things, right?
Mm-hmm.
And then the multi dimensional view of that means that uh, when you index it, then you say, okay, I want to view this as a two-dimensional array of 3 rows and 3 columns. So then you say, I want the first column and the second row, and the type does all of the maths to work out where in the contiguous array that it has to look. It's pretty handy.
And so if you're clever about, and if the system's clever enough, then you don't need to be doing all these gnarly divisions to be accessing the indexing,
Right, yeah,
which
you
is
don't need
like
to do any
up.
of that yourself. It's all handled by the type.
Yeah, we
This is
have
my
that in
plan
Julia.
anyway. Cool, nice.
Yeah, yeah, yeah. There's a lot of engineering and effort that goes into multidimensional arrays. It is
Yeah,
highly non-trivial.
yeah, for
Yeah.
sure.
All
Cool.
right, so I think we mute each other now, bunker down, and then I might just go with like a really ratchety approach to it. It's there's not going to be any regex per se. It's just great characters.
Yeah. All right,
But
cool. See
see you on
you
the other
on the
side.
side. Yeah. Okay. Let me. Okay. Now it should just be me, and you should still hear my audio. Cool. Let's get started. Hey everyone in chat. Hello for hey Boomerang. Okay, so let's get started. Like yesterday, I've got my Python script to generate me a new day, and that just gives me a little base to work off of. Okay, so we're gonna do essentially, we'll take this as our test input. So we're gonna get for each row of this, I'll make like an enum and do a little bit of parsing because this thing is going to change in part 2. Thanks to follow Mixteenth. So I think what I'll do is use get lines. Use get lines of input, and probably don't need to stick it into a vector. Let's see how we go. Okay, and then for each line, we're going to calculate the score. So std views transform calculate score, and we'll make a little function up here, which given an input line, will calculate the score for that line. So now we've got our lines. For each line, we're going to calculate the score, and then we're going to sum that up. Which we can do with TL fold scores 0 plus. If we have time, maybe we can actually implement a little alias of this so that instead of doing TL fold, we do something like TL sum scores. Just makes it a bit cleaner. I'm cat and I love it. Adopt me or reporting you. Okay, I adopt you. Sure. Okay, so calculating the score. Let's make an enum. Call it choice. Rock. What order were these in? Just so we can just do some casting to get the values. Rock, paper, scissors. Okay. So for, let's do function to return a choice from mine, because the left hand side is going to be my choice, the right hand side is going to be their choice. And we'll just switch on to C and do case A, return choice rock, case B. And, you know, we can do a using enum choice here, which is basically because this is a scoped enum, usually you have to fully qualify all of those names. This makes it a little bit nicer when you're doing like a switch statement, and all of these are going to have the same, exactly the same thing, qualifying them. And from there's, like, we could just do some arithmetic on the character and do it that way. But this is just like a little bit clearer. Okay. So given a line, then mine equals from mine line 0, and then there's a space, and then theirs equals from theirs line 1. Okay, so now we've got whether we picked rock, paper, scissors, and whether they picked rock, paper, or scissors. And now we need to work out if what the score is for this choice. And this is where I'm going to show MD span, I think. So basically what we can have is an array. 2 to skip the space, yes, thank you. We can have an array of 9 integers, and we'll call this score map. And this will be, so rock against rock is a draw, rock against paper is a loss, rock against scissors is a win, and then paper against rock is a win, paper against paper is a draw, paper against scissors is a loss, and then scissors against rock is a loss, and then a win, and then a draw. Okay, so this is a this is a one-dimensional array of small note ABC is their choice. Oh, yes, thank you. That would definitely give me the wrong answer. Thanks for catching that. And let's just swap these around. Okay, so now we've got score map, which is a one-dimensional array, and now we want to be able to index this without having to do any maths. All right, so let's use MD span. So I think MD span is in VC package. So I should just be able to do MD span here, generate, and this should go and grab it. Run a VC package install down here. So MD span is a multi-dimensional view or span over a one-dimensional contiguous array. It's taking a bit to work, but why don't I show you what MD span looks like. So it's going to be in C++ 23, I believe. This is a reference implementation. And basically, whoa, my monitor just turned off. Okay, it's back. Tutorial style introduction. So basically what they do is, you can have a stood span, which is a view over a contiguous range, a one-dimensional view, or you can have a multi-dimensional span. And this says that we're going to take a view over data, and it's going to have 2 rows of 2 ints each. So this is dynamically sized. You can also have statically sized extents, or mix them even. So this one says that my extents are, we use int to represent the extent itself. Our columns are going to be dynamically sized. Our rows are going to be statically sized to 4. So this lets you mix and match, basically. It's pretty handy. Hopefully this is... Okay, this is downloading MDSpan at the moment. So what... it's been a while since I used this version. What namespace do they have everything in? Experimental, MDSpan. Do they literally use std? Namespace. Yep, std experimental. Okay, well, let's give it a try. Maybe this was a mistake. Maybe I should have... I mean, I didn't know that I was going to use MDSpan. So I'll just let that install. Oh, there we go. Okay. So let's go add that to my CMake. Std MDSpan. Std is the namespace for CMake as well. That's a nice touch. And we need MDSpan. Alright, so now I should be linking against MDSpan, and in theory I can now do experimental, yes, experimental MDSpan. Nice, very nice. Okay, so then I can do std experimental, oops, MDSpan, a span of ints. My extents are going to be I guess std experimental extents, yes, int 3. Okay. Score span, and construct it with score map. So this will now give me a 3-dimensional view over this 1-dimensional score map. So then I can do return score span. It currently uses the call operator for the indices, but C++23 adds multi-dimensional indexing for square brackets, so it will use that in the official version. So this will be std to underlying mine. That just converts an enum to its underlying integral representation. To underlying theirs. So that should give me back the whether we won or lost. We'll build this and work out what all these errors are in a sec. And then was it plus 1 for, what was it? 1 for rock, 2 for paper, 3 for scissors. Miguel's just saying something. 1 sec. Yeah, there we go. Yeah, I'm doing a bunch of nonsense with MD span at the moment. I think we're almost there.
Oh
yeah.
Lord, I very much, I'm being really silly, really silly. I think I just thought of something. All right, see you in a bit.
Yeah, good luck. Okay, back to our nonsense. Okay, and then it was plus 1 for rock, 2 for paper, 3 for scissors, so just stood to underlying mine plus 1. That should do. Hey Martin Lemons, we're doing rock, paper, scissors. Alright, let's build this, see what happens. So this should give us back our score for each line, and then we just sum up all of the scores. That's what the puzzle was, right? What would your total score be if everything goes according to theirs versus theirs? Yes, thank you. I before E. But no, that's the wrong one. I can spell, honestly. And I need to hash include TL fold. What's this saying? I think some error with am I using MD span wrong? It has been a while since I used this type. I also need to default construct the extents or something. MD span extents. Data rows. Maybe it's just IntelliSense. So saying no CTRE target was found. I've stuck a comma after the CMake thing. I do love CMake. It's special. Okay, well, CMake generated at least. Let's see if you're gonna build. Okay, what's happening here? Internal compiler error, oh my god. Error. No overloaded function convert all the argument types. Oh, I need to take data from, because this is a std array. Here we go, our first internal compiler error on stream. Well, it's std experimental, so I guess it's is that my fault? Yeah, so I was trying to pass score map, which is a std array, but it needs to take a pointer. Alright, so this says 15. Is that the correct answer? 15. Yay! Let's get our puzzle input. Long. And give this a shot. 10,595. Don't know if you can all hear that. Someone's screaming outside my window. That's the right answer, yay. me just tell Miguel that we're done with part 1. Hey, we're done with part 1. Gonna move on to the second part.
I am writing down my table result in shame.
I got MD span working, but I did ice the compiler before I got it working.
So for our friends who don't know, ICE means internal compiler error, and if you get them, you get a high five from a stranger on the internet and a lot of nerd points and a very, very sad computer.
Yeah. All right. Catching a bit. Okay. Have a look at some of the questions in chat. Blake Booyah, how many, if any, books on templates did you work through to get to the level? I didn't read any books on templates. Well, no, that's not true. I did read the entirety of Modern C++, design by Alexandra Escu, but that is like C++ 03 metaprogramming, which is very different from the kind of stuff we do now. I learned most of my template stuff from answering Stack Overflow questions wrong and having people tell me why I was wrong, by just writing a lot of template code, by reading template code. It's all practice. Like when I did my implementations of std expected and std optional, which have a lot of template nonsense in them, like a lot, because it has to work I want it to work with C++ 11. I basically just had to learn a lot of the standard library tricks which go on in standard library implementations or in Boost and things like that. Like making yeah, so it's basically reading code, practicing is the way I learned it. VZW Gray's asking, would I mind quickly explaining how the score map works again? Yeah, sure. The score map is basically a map from rock, paper, scissors. So this is so basically what I do is it's like a map essentially. I'm saying, okay, the first row is for if you pick rock, and then the first column is if they pick rock, the second column's if they pick paper, the third column's if they pick scissors. So it just encodes the victory points, because the problem says that you get 3 points for a draw, 0 for a loss, 6 for a win. So I just encode that into this one-dimensional array, and then I take a two-dimensional view of it with MD span. Okay, let's have a look at part 2. My guess was that in this one they're going to change what X, Y, and Z mean, and it's going to be whether you lost, drew, or won, and then you have to work out what the opponent picked. Let's see if I was right. Okay, part 2. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you lose, Y means you draw, Z means you win. After you do like a bunch of these puzzles, you start to you like look at the problem and you think, oh, this is how it's going to change for part 2. Like sometimes they do the most difficult ones, I think, if you do them wrong, are the ones where part 1 seems like reasonably sensible and easy, and part 2 is just, okay, just do exactly the same thing, but a million iterations or something like that. And if you have done part 1 in a the like naive way, then your solution will be too algorithmically complex for the size of the input or the number of iterations you need to do, and there's like some trick which you need to work out to make it actually feasible to run the amount that part 2 wants you. So anyway, the total score is still calculated the same way, but now you need to figure out what shape to choose so that the round ends as indicated. So In the first round, your opponent will choose rock, and you need the round to draw, so you'll also choose rock. This gives you a score of 1 plus 3 equals 4. Okay, so the calculation is exactly the same. It's just the from mine function, which is going to change. So let's call this from mine part 1, and from mine part 2, we're going to return let's make a new enum. Result, lose, draw, win. And this will return a result. And then this will return lose, draw, win. Okay. So actually, we'll call this choice from mine, and we'll call this result from mine, because these calculations are going to be a bit different. Lack of a default case in these switch statements scares me. What are you going to do? So we'll call this choice from mine. Calculate score part 1, because then I can use exactly the same code in part 2, and this is just going to be calculate score part 2. Okay, so instead of choice from mine, we're going to get a result from mine, and then we're just going to edit this score map. And instead of an int, this is going to be a choice. Is that right? And so on a rock and a loss, then you return, let's do it using enum choice. On a rock and a loss, then we're going to play scissors. On a rock and a draw, we're going to play rock. On a rock and a win, we're going to play paper. On paper loss, we play scissors. Well, wait. Yeah, on a they play paper, we need to lose, we play rock. Yes. And then paper, scissors, paper, and rock. Okay, so this gives us back our the choice we need to make. It's an MD span of choices. So then we have our result. So our score from our result, let's just make a function here. Okay, switch on R. If we win, oops, using enum result. If we lose, return 0. If we draw, return 3. If we win, return 6. Okay, so score is score from result mine. So score plus, and then we're gonna do the score map with mine and theirs. I don't know, theirs and mine, instead to underlying mine. This will give my choice. And we just do to underlying my choice plus 1. How's that look? Let's build it. Well, it's building. Ooh, many bad. My choice cannot be used before it's initialized. No matching overload can be found. What's going wrong here? Oh, did I break something in part 1? Oh, whoops. I've been editing part 1 instead of part 2. Whoopsie. Because I didn't make a copy of this function. Okay, let's copy it and then just walk back all of those changes. Or just leave it. You know, I can rewrite the part 1 stuff pretty easily. Let's just forget about it. Comment out part 1. And I can fix it later. The extents, I did update the extents type both here and this type is for storing the value of these, not for storing anything in the underlying one. 66. Yeah, I don't think that needs to be a choice. I think it's like if you have dynamic extents, then it needs to use some type to store what the value of those extents are. Just going on here. Term does not evaluate to a function taking 2 arguments. Why not? Anyone see what I'm doing wrong here? I don't understand why that's not working. Yeah, thanks. Score span. Thanks, Pertoof. Build succeeded. Okay. I feel like I probably got something like slightly the wrong way around at some point, but let's give it a shot and watch this say that it was the wrong answer. That's the right answer. Yay, we did it. Let's, just because I don't like leaving this in a way which doesn't quite work, let's go back and rewrite the part 1. This was rock versus rock, rock versus paper is a loss, rock paper 3. Paper versus paper is a draw. Paper versus rock is a win. Loss. Loss. when draw. And this was an int. We didn't need this. I think that's right, isn't it? Something like this. And then we can just double check that this is for, like, you know, if people find my GitHub repo or something and they want to run something and play around with it, it's nice if it works for both parts. I need to remember to copy paste stuff if I'm going to reuse some code for both parts. 12677, was that right? Was that what I got the first round? It was not. So I made a slight mistake in rewriting this. What did I do wrong here? Rock versus rock. Rock versus paper was a loss. Win. I'm not sure. Maybe I'll look at this again off stream, but basically we got the right answers, so that's the important part. Let's tell Miguel. Hey, we're done.
I don't want to talk. I'm not doing this. I just did a huge bunch of ifs. It feels dirty but simple. And like I gave up halfway through. It's just, this is not a good feeling leaving my body right now.
So people should be able to now see Miguel's screen on my stream.
Oh Lord. All right, it's just all right. Never do advent of code at like 7 in the morning. That's like the biggest takeaway. Debugging is a good. Debugging is a. I was about to say debugging is a good sleeping tool. Sleeping is a good debugging tool.
Yeah, it's almost 2 o'clock where I am. I've had coffee. Right. I made masala chai just before we.
Oh, you're just rubbing it in now.
Sorry.
All right. No, that's fine. All right, so this is a tie, and then you rock versus scissors. No, that's the one. That's it. I think that's where I was being silly. Rock versus paper. Yeah, I didn't know how to do rock paper scissors for a bit there. All right. Then paper versus rock, you win. Paper versus paper, you tie. Paper versus scissors, you're done. Scissors versus paper. Scissors versus paper, you win. No, see, this should have been rock. The next for here for this one, rock, and this one is paper. There we go. If scissors goes against the rock, you're gonna lose. If you go against yourself, and then scissors versus paper, then you're supposed to win. All right, scissors versus paper, yes, and then okay, finally, I got part one, guys. Gang. Yeah.
Oh, in fact, your code just so I got the right answers, and then I accidentally overwrote my part one code, and then tried to rewrite it, but made a mistake. But your stuff has just made me realize what the mistake I had in rewriting part one was. So.
Oh, which that's very kind. Who was this?
No, this is yours. I flipped around some arguments. Nice. Yeah.
Okay, great. So you're done with part 1 and 2, right?
Yeah, I'm done with part 1 and 2. Yeah.
That's the sound of a person that made wise choices when coding. All right, so now this should be there we go, and for good measure, let's just put this into the clipboard. So I love this function. If you do clipboard, I'll just put it in, and then I can just. You're too low. No.
So, like, what was your code?
So, it's just a huge lookup table.
Okay.
So I just encoded the, hey, if you chose A, B, or C, that's like P1 minus capital A plus 1. And then, because you get the most points for choosing rock, right?
You're. Oh, okay, wait. You flipped some stuff around, like in your. Sorry, I'm just getting confused because you have like Y X Z and then X Y Z and then X Z Y.
X, Y, Z. So here, I can do one better than this. Oh, no. Whoa. Um, this is messing. So, okay, my cursor was somewhere else. There we go. What is going on? Yeah, it's flipped. I'm probably just gonna use the REPL next time.
Mm.
This is way too much for me. All right, so yeah, this is A. Um, this one should have been the start. Rock versus rock. Rock versus scissors. Rock wins against scissors. Uh, paper. If you're the paper and they are rock, you win. Yes, and then you chose that. And then paper versus paper. Then it's a tie. Paper versus scissors. You lost. Scissors versus rock. You're the scissors. You lost. Yes. But okay, see this one. I flipped this. Yes, this should have been. How do I? Uh, nope, not that. There we go. It should be rock versus rock. Yeah, I
Have
think
you
I've all.
have you tried it with the test input and seen
Yeah,
what you get back?
yeah, I did get the 15. So here, let me try it again because new file. Let's do 02T test. Like a brave man, just hard coding it. There we go. And then when I did that, da, 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 I'm gonna realize something really silly. Like, uh, yeah. So this one's 15,
Yep.
and these are all the. Oh, that's so. Okay, yeah. That was way too much because I was feeding in the real, not this. So in the case that it's A and Y, it should be 1 point, then 8 points, and 6 points, right? I believe so. Let's check here. Um, in the first round, your opponent would choose rock. You should choose paper. The Zinzin win for you with a score of 8. Hmm. How did I flip this and get it the other way? And the second round, your opponent will choose B.
Oh, you did what I did in the original. So someone in my comments corrected me. The X Y Z is your choice. The A B C is their choice. So your
The X,
sixes
Y,
and
Z.
your zeros are the wrong way around, and your chose points. Yeah.
So if I do this, this is on the test again. Right? So
Yeah. So
2, 7.
your zeros and your sixes are still the wrong way around. So if you go back to your code, the where you have +6 should be +0, and where you have +0 should be +6.
So this is what you meant. There we go. Reading instructions.
Yeah,
Challenging stuff.
I made the same mistake at the start. Fortunately, someone in chat was like,
Isn't having chat the most overpowered ever?
"Yeah, I wish I
It's
had it
like,
during my regular stuff."
what is GPT-3 against the Twitch hive mind?
All right, so you should
Um,
hopefully get the right answer now.
yes. There we go. Uh, and then and go. Uh, That I would have not got
Yay!
that soon. Thank you. All right, and what did this person pull on me now? Part two, the elf finishes helping with the 10 sneaks back over to you. Anyway, the second comment says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good
Yeah.
luck.
So it's
Total score.
what I guessed at the start.
Oh yeah, it's like, oh surprise, you didn't count on this one, did you? So X means you need to lose. And so you need to change your decision accordingly. Oh. Can we look at your code? Like, yeah, I can go and like do another if chart, but like, I think it's more interesting to talk about MD span.
Like I can show you my solution if you like.
Yes, I would. I very much would.
Okay. Let me.
I think because like you're gonna see me code the same logic, just like with more steps.
Yep.
I'm not gonna do anything more interesting than that.
All right. Well, my solution should be on everyone's screen. So
If I did this, so I think, yeah, I had completely borked the. If I pop it out, yeah, I lost the camera, so let me.
technical stream difficulties.
Yeah, but wow, there we go. Full screen. All right, this is as good as it gets for now. And oh, people can see you on the bottom, so fine by me.
Cool. So basically, what I did is I just get all of the lines.
It's just I just opened up a screen full of C++. I'm like, wow, this is just so violent.
Yeah. So I get all the lines, and then for each line I calculate the score,
Yeah,
and then
just
I
like this.
I sum them up. And I was saying I want to implement TL sum, so I can just do that. I think
I was gonna ask, like, what, like, I get, so for people that don't know, like, if you come from functional land, fold is the way that you can just like take a starting element, apply an operation, and then like keep adding elements of a collection,
Yeah.
or like, and like, there, it's just a way to like keep iterating over a collection and like reducing to a single scalar. And so I keep seeing like, why are they like? I'm sure that like if you do a fold with a plus, that's a sum,
Yeah.
right? And I'm like, is there no sum?
So C++ has stood accumulate, but there's a weird thing, right? So most algorithms in C++ are in the hash include algorithm header. Accumulate is not in the algorithm header. Accumulate is in the numeric header. When ranges got added to C++20, all of the stuff in the algorithm header got range-based implementations.
Defined?
So things like transform got like std views transform and remove if and all of that stuff, but accumulate did not. So there is no std ranges accumulate. It doesn't exist.
Was there like,
Uh,
is there a reason for it? Was it like
I
just overlooked? Or?
I don't know. It's a
It's
shame to be sure, but yeah, I think I'll implement a TL sum so that I don't have to write this every time. But anyway, so yeah, basically I just calculate, get all the lines, calculate all the scores, sum them up, and to calculate the scores, what I do is I get
There's our arrays. Yeah.
I just have an enum which encodes for rock paper scissors, and I have like a switch statement which just gets me back whether you picked rock paper scissors. Using enum just stops you from having to write choice :
Yeah. It's like a
start of
namespace.
everything. Yeah, but for strongly typed enums, which are enum class. So yeah, I just have I get what their choice was, I get what my choice was, and then I have a score map, which is just an array saying, you know, if I picked rock and they picked rock, then it's a draw. If I pick rock and they pick paper, then I lose, and so on and so forth. But this is a one-dimensional.
Oh, you made the table, and so entries into it are like a 2D table.
Yeah.
Ah, that's clever. Yeah,
So
well
this
done.
it's a one-dimensional array, and then I take a two-dimensional view over that array using
Look at all
mdspan.
the brownie points you're getting. This is cool. So
So
this is like
basically,
the
yeah. So this is
the
a
extent is where you get to say like, oh, I know it's 9 elements in a line,
yeah,
but please take my word for it. It's actually a 3 by 3. That's the extent,
yeah,
right?
exactly. So this is saying what my uh how to map a two-dimensional view onto this one-dimensional array. So I here I'm writing it into the as just constant
So
into this template. So this is at compile time. You can also do it at runtime. So I could say experimental dynamic extent, which says we're gonna get the size of this at runtime, and then you would pass it in here.
So that's one of the really interesting things when I was reading about MD span for me is that I remember that people were saying you can choose the row or column alignment for the array. And so we don't have that in Julia yet or out of the box that I know. And there's just like a lot of like very there so what I noticed from the proposal was that you could get a lot of flexibility for multi-dimensional arrays that would be incredibly performant impacting.
Yeah,
And if it's column or row oriented, like that's
yeah,
just a huge thing. And so there's a lot of like sort of traits for an array that you can sort of encode at compile time. And the hope is, right, that the sufficiently small compiler, that legendary beast we've always heard about, will be able to propagate that back into your code, and you could exploit all the super speed ups from it.
yeah. So you can go and and read the paper. Jesus, 18, 18 revisions.
18 revisions. Oh, so please walk me through this, because like I know that like from what I hear from people on Twitter, like just the process of being like, like I think I saw a tweet from you, was like, oh, submitted a paper I forgot about 8 years ago, and like it just made it into C++. It's just,
Oh
and
no,
like,
I submitted a paper to the dwarf
oh
standard
yeah, yeah.
six
And
years ago, which got into the standard and I didn't even hear about it. Someone wrote a paper based off of my paper, and it got into the standard. No one told me. um,
and so that's such a so when I first came into like learn a little bit about C++, and I just heard about those things, and I was like, I can send a pull request to Julia today, and if people like it, it gets discussed and it can land in a week. There's
yeah,
some PR like multidimensional syntax for arrays in Julia actually took like 2 years of back and forth and designs. It needed like a champion to push it through. I can show you in a bit. There's some really, really cool things that you can do. But um it's so amazing to me, like and that's one of the reasons why I think it's worth, like, there's a lot of cross pollination that can happen between C++ and Julia communities. I mean, obviously because LLVM and huge compilers, but like talking to a community that's like, yeah, we can't change trillions of devices and we've been around for like 50 years. Like
yeah,
we have grown to a scale never before like conceived by men or gods, and we have to act accordingly. It's hard.
yeah,
So even if you were the biggest C++ hater, I'm not. It's just like
yeah. It
there is
takes
so
a
much to
lot
learn
to
from.
get into. Like I wrote what was my paper number for? I got like a monadic interface into
Yeah,
std
yeah, yeah.
optional, which
Hmm.
I cannot remember how many revisions I needed in the
So
end.
did you just Google STD C++ committee papers?
Yeah, and then you can just find all of the papers. So and then also like if you want to find the most recent paper, you can get the paper number, which is like this thing, and just go wg21.link slash paper number. And yeah, I needed 8 revisions to get 3
So
functions into to std optional.
so is a revision like a round of people in the committee going to Hawaii and like Bike shitting it. Like it's much more than that. Like so, I don't know what a revision involves
Yeah, a
in
revision
this year.
it depends a lot, and in fact, so wg21.link, which I just used there to get the most recent revision,
Mhm.
is um, a website made by Mar Bosch, is that how it's pronounced? Who's currently in my chat saying, "Hey, that's my website." So thank you very much for for creating
Oh
that.
yeah,
Um,
yeah. Supportive stream, supportive audience. We're here for them.
so
Thank you.
a revision is usually you will submit a version of the paper, and it will be discussed in at the moment often it's like a conference call. It used to be that would have to wait until like an in-person meeting, and then you'll come back with some changes you'll have to make. Oh, whoops.
Yeah, some feedback. I
Yeah,
heard that like some committees did not want to adapt to an in-person format, even during the pandemic.
yeah,
Yeah, there's some stuff about C++ that you're like, oh wow, like they're under some hard constraints, and I can see why they had to choose that. And other stuff you're like, they what?
yeah. It takes a
The
lot of
what now?
work to get like anything into the language, really.
Yeah, it's yeah, it does. But so you get to show off cool stuff like, choosing the alignment of your arrays, having the and so what surprised me most is that like you could declare that extents way after you had declared and initialized the array. So
Yeah,
it's like it's a much lazier declaration now.
yeah. You can
And
get the data from like
so the
anywhere, and then just take a multi-dimensional view over that that data.
yeah, and so you can also specify the strides. And
Yep.
so that's so there's ways that you can do that in Julia too, but um, we're column based format for starters, and there's a lot like I, I keep thinking about like what the ultimate system for like it's not hassling but rather like bullying the compiler into understanding arrays could be, right? Because
Mm.
you can have like an entire grid of like you could have it be row wise, column wise. You could have it be strided, not strided, like linear indexing. You could have it be sparse, not sparse. You could have it be like symmetric, not symmetric. Like if you start getting into like what are all the different types of structured matrices and how much of that can I bully my compiler into knowing about?
Yeah. And some of
There
that
is
was like we had things like val array, and which got added to C++, and everyone was like, oh hey, this will be like um a Fortran style performance of doing array um multiple doing array arithmetic, because we can get a sufficiently smart compiler to like build up an expression tree of this at compile time, and then execute that in the fastest way possible. And of course, no one implemented it, and uh,
and so that's something that like obviously like I'm not the first person to be like, wow, linear algebra is hard and compilers are hard, but rather like even if those like even if we had that all that information, like I don't know of any programming language today that would let you like be able to state these are all the properties of my matrices and please propagate those for these optimizations in this way. Like even if you specified it for one array, how it carries forth through different operations and procedures, that's where like the real algorithmic boost is, right? So
mm,
that's something that is very hard, took me a while to appreciate about the C++ standard library. There's a lot of I remember you were in one of the streams saying like, oh yeah, because like if I have I'm gonna say something that's completely off base, so please correct me. But it's like if I'm implementing an iterator or a cursor and I know that it's like something something size, then I know I have random access and blah blah blah. So like there's all of these there's a lingo which the STL has for being able to specifically say we know that in all of these cases we guarantee you like linear time algorithmic lower like upper bound on this or
yeah,
or random access or constant time. And I was like, oh wow, like I've seen those as like annotations in code, just like people be like, oh, this algorithm is probably n log n or something. Um, but I've never known, like, I didn't know that you could sort of like carve out interfaces where you would promise users like this will always be linear if you fulfill these consequences, and constant time if you happen to implement these methods on your
Yeah,
iterator.
that's basically like, yeah, if you say that my iterator type, this iterator type is a random access iterator, you're promising that you can jump to any element of the range which it's logically specifying in constant time, uh, and you could like theoretically implement something which um, which returns true for is random access and doesn't give you constant time, but you are breaking the like semantic rules of the standard library if you do that. So there's like there's we have facilities for specifying that yes, I am random access, and for checking syntactic constraints
Conformance.
and yeah,
Oh.
conformance to something being random access, but we don't yet have the facilities for uh, like at compile time checking the semantic requirements of those. You are making a
But
promise to users, which
that's the
can't
thing. Like
necessarily be checked.
C doesn't have it. Julia doesn't have it. Like Lean 4 doesn't have it, and
Mm.
they're really smart about like trying to prove properties at compile time. But like, it, like there's even like languages that are built on top of like formal verification and formal proofs, and it's like, oh yeah, we don't know how to do like linear algebra the proper way. Like, who knows? Because at some point it's just like you're just proving all this stuff about matrices.
Yeah, I mean, I guess
Prop-
I assume at some point I can't remember like reading properly about this, but I assume it gets into the halting problem at some point. Like you can't prove exhaustively the algorithmic complexity of an arbitrary indexing algorithm or something like that.
All right, but could you like maybe constrain the problem in some bit so that I don't know. I,
Yeah, I mean, basically what we do is we say that uh, if you if you are an iterator type and uh, you want to be able to move forward and backward like a bidirectional iterator, and then you implement the increment and decrement operators, and that lets you move forward and backward. If you uh, if you implement the indexing operator, like square
then
brackets
that's
operator, then you are promising that that is constant time. And if it's not constant time, then well, you done goofed.
you done goofed. Yeah. Um. Yeah. So I think one last question before we split ways. And unless you have any more questions about Julia that I could maybe answer, there's the keywords for layout left and layout right, but they mean something specific when you're declaring. Oh, we have a cat.
We have a cat. This is Milkshake. She is Chaos
Milkshake.
Goblin.
Uh, I remember Marshmallow is the one that doesn't have a brain cell.
Marshmallow has never had a single thought in his life.
There we go.
Milkshake, all of
That's
Milkshake's thoughts are destroy, aren't they? Yes.
and get scritches.
Mm-hmm.
Yeah.
She can pretend to be sweet though.
Bye.
Yeah, I don't really know about the layout left, layout right stuff. It's been a while um, since I used.
Layout mapping policies.
Yeah.
Yeah. So these are the mapping policies, and so.
The
Mhm.
leftmost extent has stride 1, and strides increase left to right. Uh, I guess this is column measure, row measure, or something. Maybe I can't remember. Anyway,
Right.
there's a bunch of stuff in this proposal.
Oh yeah. And yeah, so you can say, oh, for this dimension, this is the stride, and for this dimension, this is the stride,
Mm-hmm.
and so you're like, wow, that's a lot of configuration that I don't know if I'd want them. Like, I don't know how all that machinery will actually play out, but
Yep.
it's I'm all for C++ people experimenting the crap out of things, and then Julia people just going, "Oh, that's neat," and then stealing the good stuff.
Yeah, that's what language cross pollination should be, right? Like you look at what all the other languages are
Hey,
doing, and you steal the good stuff, and you leave the bad stuff behind.
like there, like no one's ever gonna rebuild LLVM and Rust. Like it's
Yeah.
just not happening, and I don't know that it would be a good idea to do so. And it's yeah, it's just like, oh, they have a JIT and they've thrown like a couple gajillion PhDs at optimizing stuff. Like that's our backend. Just, yep, do
Well, I
that.
mean, like there are things like crane lift is coming in, and the WASM infrastructure is built on top of crane lift, which is completely separate from LLVM. So people are like building um, like realistic alternatives which are being used in production systems. But yeah, LLVM is like an incredible piece of technology.
Yeah. There's so in the compiler landscape for Julia, we're gonna get native code caching. So all the JIT stuff that happens, you'll be able to cache native code, and so it's gonna cut down on JIT compilation times incredibly. It's gonna fly.
Yeah, that's pretty cool.
We haven't got our story together for WASMs though. Um, Julia should be a really good WASM place, but it just hasn't. Like people haven't ponied up the time.
Mm,
It's more like, yes, it's doable. We have the engineers that could do it. It's more like people have to like pay for them to do it. It's
yeah.
not like it's completely infeasible. It's just like and people. So, but yeah, priorities are hard. There's always more work to do in open source than there are people. So,
Yeah, for sure. All
all
right,
right.
I think I'm gonna drop off. This
Yep.
was fun. Thank you very much, and I'll see you tomorrow.
Yep. All right. Good luck with the elves
Yeah.
and Marshmallow. Take care.